All right, so this is day 2 of your notes for 6D. And so I'm going to give you a little example here because this is kind of a little bit confusing, and then we're going to talk about what this really looks like. So let's just say that you're in a courtroom and you get a jury's decision, and the jury's decision is guilty. And so, but the truth is that they were really not guilty. And so if somebody's guilty, but the truth was they're not guilty, then what happens is that the innocent person here could go to jail. Now, what happens when we say they're guilty and they really are guilty? Well, this is the correct decision. So that's what we're looking for. That's ideal. Okay, but what we have here is when it's not guilty and they say not guilty, again, this is correct. This is what we want. But what happens when they're not guilty, but we say they're guilty? So now the guilty goes free. So the question says, what would be considered a worse mistake? So is the worst mistake that the innocent person goes to jail? It's supposed to be an L. The innocent person goes to jail, or that the guilty person goes free? And what most people would say is that this really kind of depends on the crime, right? It would be a shame for an innocent person to ever go to jail, but if you've got some mass murderer who goes out and is free, well, that might actually even be worse. So what we're going to do is with our significance tests, we're going to look at this and we're going to go in here and we're going to decide what happens with this, with our assumptions, and what type of errors can we get. Okay, so a jury is going to decide whether the defendant is guilty or not guilty. And not guilty here, we're going to say not that they're not innocent, right? When you go to court, it's you're either guilty or not guilty. We don't say you're guilty and you're innocent, right? So think about that when we do this. When we say reject or fail to reject, we're not saying accept. So that's kind of where this is coming from, okay? So we will decide whether to, whether to reject or fail to reject the null hypothesis. So that's where this is. If you look at this in terms of our little example here and what we're trying to do. So what we're doing here is this is what we're looking to get in a significance test. This is what we're looking to, I don't want to say prove, but we're looking to validate, okay? So what happens in the courtroom? They always start with the assumption that the defendant is innocent, or we're going to say not guilty. You know, you've heard that innocent until proven guilty, right? So that's how we're going to start. We're going to start this. And this is the same thing with the significance test. We're going to assume the claim, and the claim is always going to be our null hypothesis. So our claim is true. Very important. We always assume that this is true. Okay, then the court goes in, they present their evidence, and a decision is made. So to do this, what are we doing? We're finding our p-value from our sample data. And really what we're looking for, and this is what's very important, is we're looking for this p-value. Okay, so we're going to create a chart. And this chart is something that you're going to want to create every time you are tasked with finding the error or evaluating the error. Okay, so stick with me as we fill this out. So we're going to have a decision, and our decision is either going to be to reject or fail to reject the null hypothesis. This is going to be our decision. Okay, and then up here is going to be the truth. So what type of errors do we think we could see? All right, so let's fill this out. Let's say here our decision is to reject the null. Now, when we reject the null, this means we have evidence for our alternative hypothesis. Okay, so when we do this, what we have here is we could have different orders. So let's say that we reject the null, and this is fail to reject. So this means we're going to stick with our null hypothesis. Or the other option we can have is that we reject the null. Okay, so this means we have evidence for alternative. So think about this up here. So if they're guilty, they're guilty. If they're not guilty, they're not guilty. So if we reject the null, we're going to reject the null. Okay, so when this happens here, we have the correct decision. And we're going to call this power. Okay, it's what we're looking for here because we assume that the null is wrong, and this is why we ran the test. You're not going to run a test usually if a company says something. So if we think about our example yesterday where we had 80%, you probably wouldn't run this test if you just believed it, right? So if we reject the null, so we have evidence for the alternative, we have evidence for the alternative here, this is the correct decision. Now, if we reject the null, and we should have failed to reject, we have here a type 1 error. So we reject, but shouldn't have. And I'll give you an example of what that looks like here in a few minutes. Okay, so the other decision that we can have is we can fail to reject, which means we're going to stick with our null as being the correct answer. So if we do that, then what happens over here is we know that this is the correct decision. Okay, fail to reject, fail to direct, we're good. There's and then with this case, there's no special word. It's just a correct decision, no error. Okay, now if we fail to reject, but we should have rejected, but we should have rejected the null, then this is going to be a type 2 error. Now, when we talk about error, this is not a math mistake. So an error here is not a math mistake. It means that your sample data gave inaccurate, I don't know how to spell that, inaccurate sample proportion. Okay, so it's not a math mistake, so that's not the type of error. It's just saying that our sample told us to reject or fail to reject, and we didn't. Okay, and when we talk about power here, this power is because, and let me reiterate this one more time, because we run a test, we assume H sub A is going to be correct. So that's why this is this decision, right? That's why it has a special name there of power. All right? Okay, let's keep going. So we're gonna look at a little example here, and there's some graphics to kind of help you out here. So this example is our hypothesis, our null hypothesis says you are not pregnant. So if you go to the doctor's office, they're going to assume that you're not pregnant, okay? And guys, obviously we're talking about women here. So, but the assumption is always that you're not pregnant. So the alternative hypothesis is that you are pregnant. So you go to the doctor's office, it's always assumed you're not pregnant until we get the test that tells us otherwise. So what we have here is we have these decisions. So let's look at this and see if this kind of makes sense. So we assume the alternate hypothesis. So this means we accept H sub A. So if we accept H sub A, and the truth is you are pregnant, which is H sub A, and the decision is you are pregnant. So what happens? The data tells us that you are pregnant. We go in here, and we say that you're pregnant, so this is our decision, and this is what the truth is, and look at our little diagram here. Hey, that looks great. Now, this is an example of a type 1 error. So this is a type 1 error. So the truth is you are not pregnant, but the decision is you are pregnant. So, perfect example. The truth is you're not pregnant. In this case, this man could not be pregnant, but the decision, what we said, our decision was that you are pregnant. This would be an example of a type 1 error. Okay? Now, let's say we stick with the null. We fail to reject. So we fail to reject. So the truth here is that you are not pregnant, right? So you're not pregnant. And what we said was with H naught that you are pregnant. So we're sticking with H naught, and we said we were with H naught, so we're good. You're not pregnant? And he's like, yeah, obviously. All right? So final example. So we failed to reject the null. So the decision is you are not pregnant. So we're sticking with H sub naught. You are not pregnant. But the truth is you are pregnant, which is our alternative. Perfect example. She's looking at this pregnant lady saying you're not pregnant, and it's like, okay. So type 1 error. So what just happened? We rejected the null incorrectly. The probability of a type 1 error is equal to the significance level. So the probability of a type 1 error is equal to alpha. That's what this is saying. Our significance level tells us what p-value is low enough. So if we increase the significance level, we increase the probability of a type 1 error. And remember, what happened with a type 1 error is that you accepted the alternative, but the truth was you shouldn't have. Okay? So type 2 error, this is the second one that we have here. So with our type 2 error, we use this letter B for beta. And it's actually kind of a Greek-looking B. It's not just an uppercase B. And so what happens here is we fail to reject the null incorrectly. Now, this beta value is something that we don't do, so AP Stats won't investigate this. We're not going to look at this in AP Stats. We're not going to look at this probability. We're only going to really talk about type 1 errors, but it's important to know what a type 2 error is. Okay? And then what does our power mean? The power means we rejected the null correctly. So the probability that we reject the null correctly is 1 minus the probability that we reject the null incorrectly. So our power formula is 1 minus beta. Okay, and so what this is this is just the complement, and we've done complements before. So this is the complement of a type 2 error. All right. So what you need to do on your tests or on your whenever you're talking about type errors, here's what we have. So watch your variables on this. We have our null and our hypothesis. We have our hypothesis and our null. So watch your placement of this, because the placement of this is going to help with your chart. Up on the top here we have the truth, and on the side here, we have the decision. Okay, we know this is a type 1, this is power, this is a type 2, and that is what we wanted. This is correct. So as we go through this, if it talks about the error, talk about what kind of error could have occurred. If our decision was to reject or fail to reject. In fact, let me do that. So if we do this, this would be reject. We rejected, so we took the alternative. If we failed to reject, then we have our null hypothesis. So if we rejected, I'm going to say this one more time, we have our alternative. If we failed to reject, then our decision was for our null hypothesis. Okay, so our R here is reject, and our FR here is fail to reject. Okay, last page. So these relationships, let's talk about this. So what happens is type 1 and type 2 errors have an indirect relationship. So as the probability of one increases, the probability of the other increases. So as we get a type 1 error, if it increases, then we'll have a decrease in the type 2 error. Okay, our type 1 error is set with our significance level. We just talked about that a minute ago. The higher our significance level, the lower our probability of failing to reject. So as our significance level decreases, then the probability of failing to reject is going to increase. This is why alpha and beta have an indirect relationship. So if our significance level is 5%, and what this is going to say is that we have more p-values that have the chance to I'm trying to think of a good way to word this. Let me come back to this. Hold on. I'm going to try to think of a better way to word this. So the higher our significance level, the more likely we will reject the null. And this increases the likelihood that we do that incorrectly as well as correctly. So the higher our significance level, the more likely we are to reject the null. So again, lower probability of failing to reject the null. Okay, so they go hand in hand. They're inverses. Therefore, type 1 and power have a direct relationship. The probability of type 1 error increases, the higher the power of the test. So if we increase the probability of a type 1 error, then we're going to increase our power, and we're going to decrease our type 2. All right, so let's talk about how this looks when we're going to interpret an error. So what types of errors would you rather have? Well, it depends on the problems. For some tests, we want a low type 1, but for others, we want a low type 2. All right, so we don't really care about this. What we need to care about is how to interpret the error. So a drug manufacturer claims that less than 10% of patients who take its new drug for treatment of gestational diabetes will experience nausea. To test this claim, researchers conduct an experiment at the 5% significance level. What are the null and alternative hypotheses? So my null hypothesis, it tells me right here, 10% of patients. So P is going to equal 10% of patients. And the drug manufacturer claims that less than 10% of patients. So my alternative, P is less than 10%. Now, I know the way this reads, a drug manufacturer claims that less than 10% of patients, but remember, your null is always equal. So our alternative has to be less than. Okay, so this says, describe a type 1 and type 2 error in this setting and explain the consequences of each. Okay, so here's what I'm going to do. I'm going to practice writing my table. This is type 1, this is type 2, this is null, alternative, alternative, and null. Okay, so here's my little table. And this is a good descriptor of our describe. So this is our decision, and this is our truth. So for type 1, I'm going to work on just what we would say for type 1. So remember, the decision was we accept but we should have rejected. I don't want to use accept. We rejected and we should have failed to reject. So our type 1 error, we say less than 10% of patients experience nausea when they don't. When they don't. So we rejected and we shouldn't have. So explain the consequences of each. So this means the manufacturer won't do anything to fix the med because they think it's okay. Because they think it's okay. It's working. They think less than 10%, so they're not going to fix it because they think everything is okay. Okay, so my type 2 error is we say 10% of patients experience nausea. But really, less than 10% do. All right, so with this one, we failed to reject, so we said that less than 10% of the patients experience, and the alternative, the truth, is that we should have rejected because really less than 10% do. And so what does this mean? This basically means the manufacturer will use resources to fix a problem when they don't need to. All right, let's flip this over. The test has a power of 0.54. So this is my power. So remember, my power is going to be right here. So the test has a power of 0.54. To detect that the alternative is true. Explain what the power means in this setting. What is one way we can increase the power? So what this means in the setting is that the probability we find less than 10% of patients experiencing nausea correctly is 0.54. Okay, so here's what we had. So we've rejected, and we should have rejected. So the probability we find less than 10% of patients experiencing nausea correctly is 10%. Okay, so in this case, it says, what is one way to increase the power? So to increase the power, remember our inverse and our direct and our indirect relationships here. So to increase power, we should increase the significance level. Okay, last part here. You know that the power of this test is at the 5% significance level. So alpha equals 0.05. And the alternative against the alternative is 0.54. You decide to use an alpha of 0.01. So we go from 0.05 to 0.01. So we decreased alpha with no other changes to the test. Will the power increase or decrease? Well, what we talked about on our previous notes right here is that when we have our power and our type 1 have a direct relationship. So if we're increasing our power on this, then what happens is that our power will decrease. It's a direct relationship. The probability we reject H sub O. So the power will decrease because the probability, this should be because the probability we reject H sub O will decrease. Okay, so how you're going to practice this is you're always going to create this table. And remember, what we have here is basically our reject and our fail to reject. And so we have our alternative and our null hypothesis. And then here we have our null and our alternative hypothesis. And you're going to put in context, like we did with this problem up here, what does that look like? What does that look like in terms of our context? And that's what your homework is going to be. It's going to be all about creating this table and then just analyzing it. Okay, so hopefully we have time to do some of this in class.